right, so we're talking about factorials. Factorials allow us to rewrite multiplication of an integer multiplied by all integers below it with a special name and symbol. Factorials can be reduced within fractions. So here we have 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 5,040. Well, this 7 times 6 times 5 times 4 times 3 times 1 can be written as 7 factorial, and that factorial is written with an exclamation point. So in general, if n is a positive integer, then n factorial is the product of all positive integers from n down to 1. So 1 factorial is equal to 1, 2 factorial is 2 times 1, which is 2, 3 factorial is 3 times 2 times 1, which equals 6, 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 5 times 4 times 3 times 2 times 1, which equals 120. And 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, which equals 720. So let's go do some factorial examples. So if I give you example 1 of 8 factorial over 5 factorial. Well, on the top, that means we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. Well, because this is all multiplication, and this down here is also all multiplication, then we can divide out the common factors. So if we want to cross out the common factors, the 1s would cancel each other, the 2, the 3, the 4, and the 5. Those all cancel out. So basically what we're left with is 8 times 7 times 6, and that's what those dots are, is multiplication, which equals 336. Now there's a simpler way we can write this out, and I'm going to show you that. So that or is telling us we can also write it this way. So 8 factorial over 5 factorial. So we can then, we know the 5 factorial will cancel out with the 5 factorial on the top, all the numbers from 5 to 1. So I can write this as 8 times 7 times 6 times 5 factorial over 5 factorial. So I can then just cancel out the 5 factorials, which still leaves me with 8 times 7 times 6, which is still 336. Now, in this, there's not too many that we're writing, so you're like, well, it doesn't matter. I'm going to show you an example where we won't have to write as many numbers, okay? I'm going to show you that here in just a second, and that's the reason we learned to do this. All right, let's look at example 2. So for example 2, we are looking at 10 factorial over 7 factorial. So we're going to take the top 10 all the way down to where the bottom is at 7. So 10 times 9 times 8 times 7 factorial over 7 factorial. Now my 7 factorials will cancel, and I am left with 10 times 9 times 8, which gets me 720. All right, let's look at another example. So for example 3, we are looking at 8 minus 3 factorial. Well, here I have to follow my order of operations, so I'm going to have to subtract before I do anything. Well, 8 minus 3 is 5 factorial, so that will get us 5 times 4 times 3 times 2 times 1. This time we're not dividing by anything, and that will get us 120. All right, let's look at example 4. So for example 4, we have 8 factorial over 5 factorial times 3 factorial. So that's going to get us, on the top, 8 all the way down to 1. But this 5 also goes down to 1. Now, the 3, we can't count, we can't divide out both at the same time. So what we're going to do, like 5 factorial is bigger, so we'll stop at the 5 and then we'll spread the 3 out. So we'll have 8 times 7 times 6 times 5 factorial over 5 factorial. But this 5 factorial cannot cancel out the 3. So we then do 3 times 2 times 1, if that makes sense to you. You can only cancel from the top. If you're doing the bottom part, you want to pick the bigger ones so you write out less numbers. So in this case, our 5 factorials will cancel each other. On the top, we have 8 times 7 times 6. And on the bottom, we have 3 times 2 times 1. Well, 8 times 7 times 6 is 336, and 3 times 2 times 1 is 6. 336 divided by 6 is 56. All right, example 5. So for example 5, we're looking at 9 factorial divided by 5 factorial. So we've got 9 times 8 times 7 times 6 times 5 factorial. I realize now I have a lot of 5 factorials in there. It doesn't always go there. And we've got some 3 factorials and 7. And then on the bottom, we'll do our 5 factorial. The 5 factorials will cancel. We have 9 times 8 times 7 times 6, which equals 3,024 when we multiply it out. All right, let's look at another number, or another example. Example 6, we have 26 factorial over 21 factorial. So this is going to start to help you see why you don't want to write them all out. I don't want to write 26 all the way down to 1 and then 21 all the way down to 1. So if I look at 26, I'm looking at 26 times, I'm going to stop at 21 because that's where my denominator is, so 25 times 24 times 23 times 22 times 21 factorial over 21 factorial. Well, that'll equal 26 times 25 times 24 times 23 times 22, which will get us, I'm going to write the answer down here, 7,893,600. Big number. All right, so we can kind of see why we want to be able to use those factorials. And you will use this, if you're taking contemporary math, you'll use this in combinations and permutations. So example 7, we are looking at 500 factorial over 499 factorial. So here's some really big numbers. We do not want to write 500 all the way down to 1 and 499 all the way down to 1. Instead, if we write this with factorials and stop at 499 factorial, those 499 factorials will cancel, and our answer is just 500. Way easier to write that this way than to write all of those numbers being multiplied.